morning to one and all. My name is Rupa. I am the team leader and these are my team members, Malvi, Mulchita and Sangeeta. Our project guide is Dr. Wright Rakesh sir. So now coming to the presentation, the title of our project is Detailed Preserving Multi-Exposure Image Fusion based on PAS. So now coming to the content, we are going to explain this. Now coming to the abstract. So these multi-exposure image fusion have required much attention in recent years because it can construct high dynamic range images. High dynamic range images is a high quality images which is similar to human perception. Due to the low dynamic range images, the significant details may not be preserved. So we propose an efficient multi-exposure fusion. These weight maps are then refined using a guided filter and the fusion is performed using a pyramidal decomposition. So now coming to the introduction, to acquire the significant HDR images and improve the subjective and objective evaluation of the fusion effect, the multi-exposure image fusion scheme was proposed. The multi-exposure image fusion is the process of combining multiple images with complementary information into a single image with optimal information. So the primary goal of MEF is to retain the most informative parts of each exposure image by extracting the weight maps and blending them into a single HDR-like images. This is about the multi-exposure fusion. It is the process of combining multiple images. We are taking the multiple exposures, which is a low, medium and high. Then we are going to fusing with images, which is a high quality image. So this is a literature survey. In but they use the pyramidal decomposition technique for the weight extraction. In muttons they use the contrast saturation and well exposedness for the weight extraction, and in Jang they used the bilateral filtering process. So in the proposed method, we have three types of techniques for mapping of input exposures. That is a principal component analysis, adaptable exposedness, and saliency map. So this is the flowchart of our proposed method. We are giving the input images, then which is a multiple exposure images. Then we are applying the PCA maps, adaptable exposedness, and saliency map for the weight extraction. After that, we are combining all these weights for the final weight. Then we are applying the pyramidal decomposition for the fused image.
Now coming to the PCA weight extraction technique, while performing PCA on images, one must create a flat vector of features where each pixel intensity is a feature and each image is represented as a flat vector. For example, if you have 16 by 16 grayscale images, you should convert them into 256 values and then use it onto the PCA data. It is one of the most well-known data compression technique. PCA assists us in identifying patterns based on the correlation, or it is simply a feature extraction technique that allows us to drop the least important information while retaining the most important information in the data set. Now coming to the adaptive well exposedness for weight extraction technique. Adaptive well exposure is a feature used in weight extraction. It will extract red, green and blue channels separately for a given exposure image using Gaussian curve. The weight aims to maintain pixel intensities that are not close to 0 or 1. As a result, the favor pixel intensity in well exposedness pixels for weight extraction will be 0.5. However, this well exposedness feature is not sufficient for bright exposure images, so we are using a well exposure based on the mean of pixel intensities in the exposed image. So the adaptive well exposure image that we propose it is used to allocate large weights to dark regions when the image is long exposure and small weights to bright regions when the image is short exposure.
Coming to the topic saliency weight extraction technique. A saliency map is simply a region in image that is highlighted and first noticed by human eye. The saliency is used to extract the weight. The absolute value of difference between intensity of pixel and the reference grayscale intensity determined in this purpose. Saliency maps are used to assign higher weights to the image regions that are more appealing to the human eye. This has a specific algorithm known as saliency algorithm. Coming to the final weight and fusion. In final weight, we are combining all three weights that are we discussed earlier. The weight map extraction algorithm relies on the principal component analysis and adaptive weight exposedness and saliency map. These maps are refined by a guided filter, and then exposure images are fused via image pyramidal decomposition. Where guided filter is a edge preserving filter, it is referred to as a guided filter. This guided filter is applied to weight maps to reduce the discontinuities and noise. Pyramidal decomposition is used to avoid the artifacts such as halo effects, etc., sharp texture, color, and color transitions.
Coming to the result, these are the results we have calculated. And we have compared with the Vulcan references, and we improved the results in as compared with the Vulcan references. These are the some of the images we have references and calculated. These are the some of the references we have calculated and compared, and these are the tabular proofs, and we calculated the and in execution we calculated the EMF, MEF, SSMI, and runtime, and improve the output as compared with the other references. Coming to the conclusion, the proposed MEF is widely used for obtaining HDR high quality images, and numerous studies in this field are available. In general, the weight map characterization process differs between existing methods. The weight extraction based on the PCA, adaptive exposedness, and saliency map is introduced in this paper. The obtained weights are refined using a guided filter, and image fusion is performed using pyramidal decomposition. In the future, the proposed algorithm will be optimized to improve its statistical and visual performance while also reducing the runtime complexity. These are the references we have referred. Thank you.